Hi everyone, it's Coach Fred, and today I'm going to be talking about translating the tangent graph. So very similar to sine and cosine, we can shift a tangent graph left, right, up, down. The difference is going to be that we doesn't really have an amplitude, because remember that amplitude was like half the distance between the maximum and the minimum. So it doesn't have amplitude, but it does actually stretch. So well, we can still call it the amplitude. It's really a vertical stretch or shrink. But it doesn't really meet the definition of what amplitude is. To find our period, similar to sine and cosine, we're going to take the general period of tangent and divide it by b. Except we have to remember from the tangent graph that the period is not 2 pi, it's actually pi. We're going to talk about that in a minute just to remind ourselves. So pi over b will give me the new period. All right, C is our phase shift, which means our horizontal translation. So it's going to move the graph left or right. And the vertical translation is going to move the graph up or down. But remember, the tangent graph is different. So let's take a look. All right, so here we've got our tangent function. Now remember, we want to use our quadrantals to help us. So I'm going to just quickly draw a little picture. Actually, let me move that. Let me put that down a little bit. So at the quadrantals, at 0, pi over 2, pi, 3 pi over 2, and back to 2 pi, the tangent's value is sine over cosine. So you might remember it's undefined at both pi over 2 and 3 pi over 2. And it's 0 here and here. So that would be at pi and then 0 or 2 pi. Now I also like to think of, for tangent, I also like to think of halfway between. There's a value at pi over 4 where tangent is actually equal to 1. So that will help me as I'm trying to graph. Okay, so first our period. Well, we have to remember that at undefined values, so at pi over 2, we're going to have an asymptote, because that's what happens when we get undefined values to a function. So either an asymptote or a whole, really. Okay, and then I'm going to put negative pi over 2 over here. And I'm going to want 2 cycles of the graph, so that's only 1 cycle. So I'm going to go in the other direction. So pi over 2, I'm going to go to 3 pi over 2. Ooh, I wrote 3 over 2. I don't know what may happen there. Okay, so then I'm going to go to the next one, which would be 3 pi over 2. And I'm going to put another asymptote. Let me do that in red. Okay, so I've got my asymptotes in, and then I'm going to put in my zeros. So at 0, I have a value of 0. And again, at pi, which would be right here, I have a 0. So we know our period is pi. We know it does not have an amplitude. We'll do the domain and range last. This is where pi over 4 is going to help, okay? So if I'm at pi over 4, I'm right about here, I'm going to be at the value of 1. And then negative pi over 4, which would be right about here, I'm going to be at negative 1. So like that. And so the graph actually looks somewhat like the cubic function. Maybe not as much of a dip or a squiggle in it as the cubic function. And then the same thing here. You can see halfway between, really, it's always going to be halfway between the 0 and the asymptote. We're going to be at 1, and we're going to be at negative 1. And you might be able to now see that amplitude would stretch it. It would just make it a little bit wider. And I could actually keep going on my tangent graph. I could go over here to negative 3 pi over 2, and I could put in another asymptote. But the graph is going to look like that. Okay? All right, so our domain. Okay, so now let's do domain and range. I'm going to do the range first because I think it's easier for you to see the range. In interval notation, it's negative infinity comma, infinity. The domain, however, we don't normally write it in interval notation because it's actually kind of confusing. So if you think about this, I can have every real number except where the asymptotes occur. Now, I think it's important for you to recognize that the asymptotes appear every pi units. So the way we could write that is all real numbers, okay, dot, dot, x cannot equal pi over 2 plus pi n. And n is just the number. So like if n were 2, it would be pi over 2 plus 2 pi. So n could be 1, n could be 5, n could be -1. So it's telling me that I'm going to add pi as many times as I want, and there will always be an asymptote from pi over 2. We'll talk about that more in class because I know that that's kind of confusing. All right, let's look at the same exact graph, but now reflect it. So not much has changed if I reflect it. I'm still going to have my asymptotes at pi over 2 and 3 pi over 2 and negative pi over 2 and negative 3 pi over 2. But remember that reflection, let me get those in. Let me get those asymptotes drawn in. Oops, not so good there. But reflection, if I go back to that graph, everything that's up is going to flip down. So it really is just getting reflected over the x-axis. So it's going to look like this. And there is my reflected tangent graph. And yes, you could put those little points on it to show it, but all right. Okay, so now let's look at translating a graph. So here we've got f of x equals -4 plus tangent 3x. There's nothing wrong with rewriting this if you wanted to, moving the 4 so that it's in the form that we talked about earlier. So we know that this graph is being shifted down 4. So, all right, now we've got to see that there's no amplitude, right? And there's no stretch either. So this makes it a little bit easier. But we do still want to go through our 5-step process no matter what, okay? So we have to find our period. Again, the tangent graph has a period of pi. So to find the new period, we do pi over b, which is pi over 3. Okay, then we need our quarter period. So our quarter period would be pi over 12. So that tells me, and let's think about this. Remember, tangent goes through that 0 point normally, but my graph now, I'm going to have pi over 12, 2 pi over 12, which is pi over 6, and then the opposite direction, negative pi over 12, and then negative pi over 6. Okay. All right, my phase shift. So phase shift left, right, that would be in this area. We don't have one, so there's no phase shift. But there is a vertical shift. That vertical shift is going down 4. Okay, again, the tangent graph doesn't have a midline, but the whole graph, I always like to think of that center point is moving down 4 units. So that starting point, which is normally tangent at 0, is going to be at -4. My asymptotes are going to be at pi over 6 and at negative pi over 6. Pi over 12 became like our pi over 4 from the standard graph, right? Like that halfway point. Remember, it's halfway between 0 and pi over 6. And since I haven't translated left or right, so that's kind of important for you to know about your graph because that's going to be your value where it's kind of turning. All right, so I'm going to draw my tangent graph like that. Now, if you wanted to plot some extra points, you absolutely could, right? That would be something that you could certainly plug in points for this, that you'd want them to be really nice points. But that's basically what happens with the tangent graph, right? So you're having to change your asymptotes. But I still think that quarter period helps us. You just have to recognize that it's every 2 that would give me my asymptote at pi over 6. Some teachers like to say, half the graph of tangent occurs on the right side and half occurs on the left side. So if you take pi and cut it in half, right, this distance would be half of it. That would be where your asymptote is. And then the distance halfway between that is where that turning point occurs. All right, so let me go back to the one we were working on. So this pi over 12 would be 1 up, right, from here, and then 1 down from here at pi over 12. So you can see that nice tangent graph that we shifted down for. And actually what's happening is that it's occurring, right? The frequency is 3 times in pi. It's going to happen. So if I wanted to keep going, I would go. Okay, so if I wanted to extend this and do a little bit more, you just have to remember there's 1, 2, 3, 4 equal parts, right? So my next line would be, my next little mark would be at 3 pi over 12, which would be pi over 4, 4 pi over 12, which would be pi over 3, 5 pi over 12, and 6 pi over 12, which would be pi over 2. Okay, so you can now see my asymptote would be here. And my -4 would be here. And my 1 up would be here. I made that really much farther away so it doesn't look the same, but you get my drift. You still need those 4 equally spaced lines. Mine's just seem to be really fat. All right, so hopefully that was helpful. Let's try another one. Okay, so here we actually have a phase shift. The good news is I didn't change the period. It's just pi. I didn't change my amplitude. Remember, we still have none and there's no vertical stretch. So the only thing that's going to change, and there's no vertical shift. So the only thing I'm working with is my phase shift, okay? And my phase shift is pi over 4 to the right. Okay, I'm going to get my quarter period. Let me do that. Which is pi over 4. Oh, that's kind of nice, right? All right, so I'm going to go over my graphs to pi over 4. I'm going to do pi over 4, and then I'm going to do 2 pi over 4, which is pi over 2, right? And then 3 pi over 4. And then 4 pi over 4, which is pi, and then 5 pi over 4. Okay, so I want you to think about the fact that normally you have an asymptote at pi over 2, right? Pi over 2, which is 2 pi over 4. That's normally where I'll put it in so you can see it. That's normally where the tangent asymptote is. So that asymptote now has to get moved pi over 4, which would move it to 3 pi over 4. So hopefully you're seeing what I mean here. So you can see my asymptote is going to be at 3 pi over 4. All right, so that means that on the other side here, I've got to have 4 equally spaced lines in between. So that asymptote that was at, so here's negative pi over 4. Negative pi over 2. That asymptote here at negative pi over 2 is getting shifted right pi over 4 as well. So I'm moving it. Oops, sorry about that. I'm moving it over here. So there's my asymptote. Okay, and so we know that our center is going to be at pi over 4, so that's where that center point that's at 0 is normally going to be. And then we've got 1 and -1. And so halfway between that, which would be at 0, and halfway between that, which would be at 2 pi over 4, I'm going to look like that. And there's my tangent graph. So it's a little bit harder, but not too much. I tend to like to shift the center point and the asymptotes first. So we're going to do a little bit more of this and put it all together tomorrow in class, but hopefully that was a helpful video.